So based on the question, which said, if a number is subtracted from its square, the result is 72, find the numbers. Both of these numbers would work, because if I plugged in 9 here, I would have 9 squared minus 9, and that is true. Okay? And negative 8 squared minus negative 8, and that also would be true, because when you do this, it becomes 64 minus a negative, and you end up there. Okay, you see why that one's true as well? Okay, so that's the first way you would use that type of thinking. Okay? Or let's go down to number 6. Find 2 consecutive positive odds whose product is 143. This is number 6 on page 235. Find 2 consecutive positive odds whose product is 143. So if this is an odd number, what would the next one be? Anybody remember? Consecutive odd? N plus 2, bravo. Find 2 consecutive odds whose product is...
Anyone who has signed up for the ski trip, please come to the office at this time. Everyone who has signed up for the ski trip, please come now to the office.
143. What are the numbers? Remember, they're looking for positive odds. I'm just going to make a note of that. You're going to see why here in a second. Positive odds. Okay, let's FOIL n squared plus 2n. Subtract 143. So, factors of 143 whose sum is 2. Positive 13. Negative 11. Is that right? Yes. Okay. Solve, and you will get n equals negative 13, because n plus 13 is 0, or n equals 11. They're looking for positive odds. So I'm going to start with this number. Why? Why can't I start with this number? Because it's a negative. So the 2 consecutive odds are 11 and 13. Okay? Again, another use for this type of multiplication, or this type of factoring. It also works with squares, area, shapes, because whenever you're finding area of something, you are multiplying or squaring the numbers. Length times width always gives you some kind of square feet, square inches. Let's look at number 10. Everybody see number 10? We're on page 236 now. The length of a rectangle. So I've got length, and I'm going to write width, because I'm assuming you're going to tell me something about width as well. The length of a rectangle is 6 centimeters less than twice its width. So I know nothing about the width, but I do know the length is 6 centimeters smaller than twice its width. Does that look like a pretty decent representation? The length of a rectangle is 6 centimeters less than, smaller than, twice its width. Find the dimensions if its area is 105. So length times width is area, right? Here's length, here's width. And I'm going to write it width times length, because that's just how I like it. And area is 108. Okay? The length of a rectangle is 6 centimeters less than twice its width. Find the dimensions of the rectangle if its area is 108 centimeters squared. So I've just set it up, length times width. I'm going to distribute it, and then I'm going to subtract. That should be a W. No, I didn't do it. I just wrote it again. 2W squared minus 6W minus 108, zeroed out. Now, you're right away thinking, well, I got to find factors of 216 whose sum is 6. No, the first step in factoring is to see if there's any greatest common factors. And there is a 2. Minus 54 equals 0. Okay? So I just pulled out a 2. Yes, that should be a 3. Thank you. That should be a 3. Okay. Factors of 54 whose difference is a 3, so 6 and 9, right? W minus 9. W plus 6 and 2. All right? Solve. The first factor, 2 equals 0. What does that mean? This is automatically going to get thrown out as part of our solution set because 2 doesn't equal 0. It is correct for the standpoint of factoring, but in the end, it didn't give us anything that can be used for the solution. W minus 9 and W plus 6. Okay. Positive 9 could be the width. Negative 6 can be the width. Can one of these be thrown out? Just for sake of logic? Can you have a negative 6 inches of something? Measure something and become with a negative and get a negative measurement? No. Even though this worked numerically, it is not going to be included in part of our solution set. That leaves me with 9. So if 9 is the width, then 2 times 9, which is 18, 18 minus 6 is 12. There are your dimensions. There's your dimensions. Okay? There's your dimensions. Now I'll actually start using the lesson because the lesson throws you into the deep end of the pool with the first problem. Page 234, example 1.
Can you organize to Mr. Mitchell's room, please?
A decorator plans to place a rug in a 9 by 12 room so that a uniform strip of flooring around the rug will remain uncovered. Okay, so I'm going to draw my room, and here is a uniform rug with a uniform strip around here. Okay, the room itself, they gave me dimensions of the room, is 9 by 12. Okay, 9 by 12. Do I have any idea how big this piece is yet? I don't. But I do know it's the same all the way around. So I'm going to call it X. Okay? I do know it's the same all the way around. So I'm going to call it X. All right. So the rug itself is 12 minus 2x. I'm just going to identify what rug is. Multiplied by 9 minus 2x. That's the area of the rug. Okay? The area of the rug is supposed to equal half the area of the room. You guys see that when you read the rest of the story there? How wide will this strip be if the area of the rug is to be half the area of the room? Well, half the area of the room is going to be 9 times 12, which is 108. 108 cut in half is 54, isn't it? Okay, so I took my 9, multiplied it by 12, and I cut it in half. Okay, that's how I came up with this. FOIL, zero out, and solve. Easier said than done, right, Mrs. Myers? All right, let's do it. 108 minus, so outside and inside. They just collected it, 42x plus 4x squared equals 54. Okay, I hate it in this order, so I'm going to flip it around. 4x squared minus 42x plus 108. This is just how I like it. Zero it out by subtracting your 54. 4x squared minus 42x plus 54 equals 0. We can factor out a 2. Remember how we did it earlier? We looked for a greatest common factor and then it got thrown out because 2 doesn't equal 0. If I pull out a 2, I have 2x squared minus 21x plus 27. Factors of 7 times 2 is 14. 2 times 2 is 4. 54, whose sum is 21. Factors of 54, whose sum is 21. Factors of 54. Hold on a second. Let me pull that out. So 54 divided by 2, 27. Divided by 3. 54 divided by 3. So 18 and 3. So negative 18x, negative 3x. Remember this old technique, guys, how we split it up, grouped? We found our factors of 54 because of A and C, whose sum is negative 21. I grouped the 18 here and the 3 here because 3 and 2 are prime to each other. Group and factor. Let's hope we come up with something. 2x, x minus 9. Yep, this looks good. Negative 3, x minus 9. Group what is shared. 2x minus 3, both are being multiplied by x minus 9. Bring down that 2 that I pulled out, even though it's really useless in the solution set because you can't have 2 equal to 0. Okay? So if I solve for 0, 2 equals 0, throw it out. 2x minus 3 equals 0, add 3, x equals, divide by 2, 3 halves. Awesome. Let's do the other one. X minus 9 equals 0, add 9, x equals 9. All right, so check them. When x is 1.5, the area of the rug checks, whereas when x is 9, the result is negative. Okay? You guys can see it right there. If you want me to go through and do it, I can, but for sake of time, when you plug in 1.5, you do get a true statement, but when you plug in 9, you get a negative number. You do not get 54. So this is going to get thrown out because we checked and found that 1.5 meters, which the thing is in meters, is true. Okay? This is one of the harder questions. Why they started it with that is beyond me. All right?